Hi there, this is the last video in a series of videos to do with the discriminant, and we're looking at exercise 3I question 16, another classic kind of question. If A and C are positive, what can be said about the graph of y equals ax squared plus bx minus c? Okay, don't get too confused. It's talking about the values A and C. I know that the general form of the equation is ax squared plus bx plus c, but this minus c means something slightly different. You can get surprisingly a lot out of just that little bit of information. Because remembering that the purpose of graphing really is to get a sense of the shape and what's happening with the data as a big picture thing. So not knowing exactly what the x-intercepts are, not knowing exactly what the turning point is or the y-intercept is not always a killer in terms of what you want to get out of the graph. All right, let's just take this through. So the fact that A is positive, and I can write that as A greater than 0. The fact that A is positive means that the shape is going to be a smiley graph. It's going to be concave up. Okay, so that's the first thing, that if I drew this, I would definitely be wrong. Wherever I draw it, it would definitely be wrong. So we've now cut it down to just one kind of graph, a smiley graph. What else? Well, the fact that C is also positive, C is positive, then subtracting C means that the constant part is going to be below the x-axis, i.e. the y-intercept is going to be down here somewhere. So I'm going to put minus C down here. Of course, if C was less than 0, if C was negative to start with, then minusing a negative number would make it a positive. So I can say that that's also possible, that I'm not going to draw a graph like this, because that would have a positive y-intercept. I'm not going to draw a graph like this that's meant to go through the origin, because that can't be right either. Or similarly, it's not going to be like this, because then I'd have a positive y-intercept as well. So it's going to have to be like this, something like that. One last thing we can do, though, to confirm all of this, and that is look at the discriminant, which is not surprising since this is in the discriminant section, but don't let that put you off. The discriminant, as you know, is b squared minus 4ac, but let's substitute in the values that we've been given. A is A, B is B, but careful of this, C is negative C. I know it's the same letter, therefore it's confusing, but just go with it. So we'd have b squared minus 4ac, but it's actually negative C. Okay, so b squared is always positive. Okay, so I'm going to put a little symbol like that there, positive. A is positive because we're told it's positive. Negative C is negative, and I know that because I'm told that C is positive. So negative positive is negative. Okay, now have a look at these three things here. I should just write it down as well, that negative 4 is negative as well. So if I look at this, I've got a negative times a positive times a negative. Now we know that two negatives when multiplied together give me a positive. So this whole thing is going to be positive. So I've got a positive and another positive, and therefore I can conclude without knowing exactly what it is, that delta is greater than 0. Therefore, two real roots, solutions, x-intercepts, but I've got two of them because delta is going to be bigger than 0. Doesn't matter whether b is negative or not, because when I square it, it becomes positive, so it's all good. So that kind of confirms again that the graph is going to have to be something like this and something like this. Now there's other things I could do to try and get a bit more clarity, like look at negative b on 2a, but you know, you can keep going as far as you want to with it, but already we've got a decent idea of the graph, that there is something on the x-intercept here, something on the x-intercept on this side. We've got a y-intercept here, so that means the turning point will have to be underneath it. We know it's a smiley graph, so we get this. It may be that the graph goes that way instead, with the turning point on this side. And I'll leave it to you as an exercise to determine, do we have enough information here to know where the turning point's going to be? Is it going to be in this quadrant here, or is it going to be in this quadrant here? Do you have enough information? I'll let you figure it out for yourself, and that'll do for this video.